Stability detection, a building bearing structure based on beam and computer vision. Lin Wu and Shunbin Wang. ZaoZhuang Vocational College of Science and Technology. Abstract. The stability of building load-bearing structure is closely related to building life. Unstable building load-bearing structure has a great potential safety hazard. The stability defect detection method of building load-bearing structure based on beam and computer vision is designed. The computer vision system for image acquisition of building load-bearing structural components is designed, which is composed of CCD camera, image acquisition card, light source, and UAV. The secondary development technology of Revit is applied to establish the overall structural information model, and the influencing factor of structural stability are introduced into the information model. Build a stability direction network model based on YOLOv4 network architecture, and implement the stability detection of building load-bearing structure. The test results show that the accuracy rate of the design method is higher than 0.920. The recall rate is higher than 97%. And the test time for the new and old building is 106.85 min and 75.41 min representatively, and different confidence levels. Keywords: beam, computer vision, structural information model, building load-bearing structure, stability test. Introduction. During long-term use of engineering structures and the reaction of internal or external, artificial or natural factor, material agent, and structural damage will occur as time goes by, which is an irreversible objective law. Such damage accumulation will lead to deterioration of structural performance, reduction of bearing capacity and durability. If the law and degree of such damage can be scientifically evaluated and effective treatment methods can be taken in time, the process of structural damage can be delayed, and the purpose of extending the service life of structure can be achieved. Therefore, the reliability evaluation method and reinforcement technology of existing structures has become a hot issue in the engineering field. Many engineering technicians and research groups have turned their attention to this field and put the identification and the reinforcement technology of engineering structures is in a very prominent position. Among them, the stability detection of building load-bearing structure is an important research content. 2. Stability testing of building load-bearing structures. 2.1. Image collection of building load-bearing structural components based on computer vision. The image of building load-bearing structure is collected based on computer vision technology. A computer vision system for image acquisition of building load-bearing structural components is designed, which consists of a CCD camera, an image acquisition card, a light source, and an unmanned aerial vehicle. 2.2. Build the beam model of the building load-bearing structure. Beam model of building load-bearing structure based on beam technology, specifically the Revit secondary development technology is used to establish the overall structural information model and the attributes of the influencing factors are customized by editing the shared pyramids to complete the function of pyramids setting of the influencing facts of structural stability. And the influence factors of structural stability are imported into the information model. 2.3. Stability testing. Building a stability testing network model based on YOLO-V4 network architecture and implement the stability detection of building load-bearing structures. The data is beam model of building a load-bearing structure is used as input data of network model to realize stability detection. 3. Experimental tests. In order to test the performance of proposed test method for the stability of building load-bearing structures, the test experiment is carried out. The test process is as follows. First, train the stability detection network model, and then set the accuracy rate and recall rate as the experimental indicators. Finally, the model in this paper is compared with that in reference 3, method 1, and reference 4, method 2. 4. Conclusion. The stability detection of building load-bearing structure is a work involving safety, which must be paid attention to. In the research, a method of building load-bearing structure stability detection based on beam and computer vision is designed. The image of building load-bearing structure construction is collected by computer vision technology, and the beam model is built. Finally, the stability detection model is built according to YOLV4 network architecture, and the stability detection results are obtained. The experimental results show that the proposed stability detection method can further shorten the detection time based on detection accuracy. Therefore, it shows that the proposed detection method based on computer vision can effectively improve the reliability of building load-bearing structure stability detection. That's all. Thank you.